So what I'm planning to present today is to give you an overview kind of thing. So because I went through the program of this FDP, and I noticed that there has been several sessions that has given the introduction on various aspects of deep learning as well as applications of deep learning. So in the today's morning session, I also listened to Dr. Dinesh, who gave wonderful introduction on deep learning. So I will be not covering more detail, I will be not taking more detailed step on explaining what is deep learning, but on the other hand, I'm going to give you an overview, particularly on presentation attack detection and how the machine learning and the deep learning techniques that are evolved over the time has helped in solving this kind of the problem. So the outline of this first session is mainly concentrated on presentation attack. More particularly, I am focusing on face biometrics. And in the second session, I am more concentrating on very new kind of the attack that we particularly identified in 2017. So we call that as face morphing attack. So the second part of the session, so after the break, will be more focused on what we did for identifying these face morphing attacks and so on. So coming back to the first session, so I am planning this session to start with a very brief introduction on biometrics. It's a very overview introduction. And while we introduce the biometrics, it is always good we try to understand like how this biometrics evolved over the time. So when it all started, so what is the history behind the biometrics, why it becomes so prominent, and why it has become a kind of everyday application for us. So for example, like if you're using your smartphone, it is very evident that we'll be using biometrics. For example, if a smartphone is having a face recognition or it is having a fingerprint recognition, then it is very evident that we are using it every day and every time for various applications. Why it is so popular with that? And then after we go through this history of the biometrics, how it evolved, then we can take a slow step towards what is face recognition. So why face recognition is famous and what are the challenges we have today and how the face recognition evolved over the time. The face recognition is not a very old technique. It got automated to the full scale since 1960. So from last 45 to 50 years, it is coming to an end with almost a kind of solved problem, especially in the constraint conditions. So when we have a nice face recognition system, obviously it has certain drawbacks. So one such drawbacks that is already in the existing since 1980s is presentation attack detection. So even though the presentation attack detection, so in the simple word, the presentation attack detection is nothing but a spoofing attack on biometric system. So what I'm planning to present with presentation attack is the brief introduction on the face biometrics. So of course, the presentation attacks is possible on all different kind of biometric modalities that we are using today. And more particularly, I'm going to concentrate on face biometrics. So in that face biometrics, I will give you like what are the different types of presentation attacks we have, like what are the possible solutions we have. And more particularly, I will present what we did from past 7 to 8 years, because we started working on this field from past 2014. So since we got our project from EU. So from there, we started contributing towards presentation attack detection on the various aspects, not just for publishing the paper, but also towards providing a solution to the industry, also towards contributing towards the standards. So the standards is very important. So as it is already mentioned that I am also a contributor for ISO ECSC 37. So we basically work there to benchmark and standardize the vocabularies what we use in biometrics, and also the performance metrics need to be uniform so that we can compare to each other when we have multiple techniques that are presented in the literature, right? So for example, some of the researchers use recognition rate as their performance indicator, and some of them will use equal error rate as a performance indicator. Some of them will use false acceptance rate at false reject rate of certain percent. So it is very important that we need to follow the uniform metrics so that we all stay on the same boat and we can be compared to each other. So that is the reason why we work for the standards. And our work is basically what I'm going to cover with our work is starting from our early work and how we evolved our presentation attack detection schemes for different types of biometric characteristics. So I basically worked with face, also the fingerprint biometrics, and also on the iris biometrics for the presentation attack detection. So I will be covering all those things there. So once we have covered all the things, then it is very important to understand what are all the open challenges. So since the field is already been addressed from 25 to 30 years from the past, obviously we have certain solutions which are close to be deployed, or there are already in solutions which are deployed. And also there are several open challenges that one need to be addressed. So the last part of this session, the first session will be concentrated on open challenges. Well, so now if we say like what is biometrics, so if you are going towards the several books or several literature, so everyone has their own way of defining biometrics. So it is well known that the bio and the metric is like the two words. So bio is something related to your biological or physical characteristics or the biological characteristics, or it may be your behavior characteristics, and the metric is how we can quantify them. So there is a standard definition in the ISO IEC, like it says that the biometrics is unique, measurable characteristics, and or the trait for automatically recognizing or verifying the identity of a human being. So when we talk about the biometrics, so we cannot choose anything in the random. So we need to choose which is unique. So there is already 8 different characteristics that can be used to quantify the biometrics, which is well presented in the literature. So among them, the uniqueness and the measurable characteristics are very important to quantify some of our physical or behavior characteristics as in biometrics. So once we have any measurable unique characteristics, we can call them as in biometrics. Well, the biometric history has a it has a very past. So the very first work, what I found on the Google is in the old Babylonian period. So it is from 2000 to 1600 BC. So if you can see the figure on the right side here, so we can identify a small fingerprint mark here. So earlier the people there, they try to use this kind of clay. They use the clay tablets for, where they have a clay and then they press the finger and they use that as an transaction authentication. So for example, like if I'm going to sell my land to someone else, then this is the way how they used to do. So they just put the fingerprint on the clay and then give it to the person who wants to buy it. So from there it all started. But even though the things are not automated at the time, but still the trustworthiness was going to be established using the biometric characteristics in this form. So then in China, it is also having a lot of long tradition of using biometric characteristics. So the first thing, the first work on the first use of fingerprints was identified in 2000 BC. So it is again the same way. So they use a clay seal was commonly used to have a various sale deeds. So finger-based identification system was also reported in 650 AD. So several historical documents on loan contract are based on fingerprints. So when we are seeing these applications, so people try to trust each other, not just by the words, but also by the way of giving a kind of consent by using the fingerprints. So then from the Western side, so there is Leonardo da Vinci. So there he tried to propose the canons of propositions. That means that how we can use different propositions of the human bodies to measure and quantify the identification information. So this is based on the correlation of ideal human properties. So then the major breakthrough happened in 1823 from John Pockeringhi. So basically, even though he did not propose anything for the identification of the fingerprint, but this is the first work that gives the details, especially on the fingerprint structure. So he tried to study different types of fingerprints. So what are all the basic pattern of the fingerprints, how the ridge will flow, and also the minutia kind of things. And he also showed that there is a uniqueness among the fingerprints within our finger. That means that all 10 fingers what we have is unique. So he tried to show that in terms of different ways of analyzing the wrist flow, different ways of analyzing the minutiae, and different ways of analyzing the patterns. So even though there is no suggestion for using this for identification. So the major breakthrough again from it is again from the Indian part. So here in 1858 there was an English officer called William James Herschel. So basically he tried to use both palm print as well as a fingerprint, especially for identification of signing the agreements. So they used to have an ink, so they tried to have an ink print, and then they tried to analyze manually the wrist flow and the patterns of the both palm print as well as the fingerprint to make sure that he's the one who signed the agreement. So this is a major breakthrough because he also discovered uniqueness between the individual, because he not just studied his own fingerprints, but he got an opportunity to study the fingerprints and the palm prints from different data subjects of all the different peoples. So he tried to compare them manually, and he identified that the fingerprints are quite unique, and also it is permanence. So even though we can have a debate on the permanence of any kind of biometrics, but to the certain extent of the life cycle, it can be assumed that the biometrics can be kind of permanence unless we damage with some kind of accident. And permanence throughout the individual life. And he also did a very interesting study of 57 years. He has his 10 fingerprints, and he tried to do the observation like how these fingerprints and the palm print of his own can do the deformation with the aging. So here are some of the figures. You can see what he has used, and especially the last figure here, if you can see my cursor, you can see these printed fingerprints with respect to the age variations. So based on these observations, he concluded that the biometrics are quite strong and it is unique for greater extent, especially the fingerprint biometrics. So then in 1882, Burlington, so these are very, very famous and well applied techniques that people have used. So he presented a manual way of measuring the humans. So anthropometry or the Burlington system was quite famous. So he tried to take the manual measurements. For example, you can see like they use the special kind of instruments, and then he tried to measure and note everything. And there are the different ways and different kind of characteristics he tried to measure and do the things. So basically, he was a police officer, so he needs to have this kind of measurement to make sure the uniqueness of the individual he tried to make. So, but one can easily say that the aging or the way we age will also change these kind of measurements. So obviously, we can see that this is not quite robust when compared to the fingerprint kind of application. Well, the another major breakthrough happened in 1900. So this is from the Edward Henry. So basically, he tried to propose an improved classification scheme. More particularly, he tried to assign each fingerprint to the way the ridge is flowing, and the way of the ridge quantification, basically the minutiae and other kind of aspects. So he used those aspects, and this has become a kind of standard to do the fingerprint classification. And this kind of scheme is quite prominent even today. And most of these commercial systems are also based on these kind of schemes as of today. And it is widely adopted by FBI in US, and it is still in use in automatic fingerprint identification system, AFIS. AFIS is quite famous in US. They use it for different applications from prison, from court to various things. So it is kind of standard in AFIS now. So if we take the history after 1900, so there are several major breakthrough in the biometric technology. So especially in 1903, so the first use of fingerprint in US prisons was evaluated. And that also gives the collapse of Burlington system. So because as I already mentioned, the variations with the Burting loan systems are too high because it try to measure all the physical characteristics. But however, the use of fingerprint with respect to the minutiae characteristics appears to be more unique and appears to be more permanence and appears to be more convenience for performing the human identification. So then in 1936, the first iris recognition system was evaluated. So as you know that the iris recognition is something related to your eye. So there is an eyeball and also the scleral region, and between the eyeball and the scleral region there is a pattern which, for example, if we are Indians, it looks dark. So when you illuminate the dark region with the near infrared lighting, we can see a nice texture inside that. So the iris recognition is quite popular because the texture is quite unique. It lasts for quite long time unless we don't discover some medical issues with the eyes. And it is a kind of not easy capture compared to the face, but it requires a lot of human assistance when you try to capture the iris. For example, if you are given your eye data to the other identification system, then probably you might have observed that like there someone is bringing a binocular to your eyes and you try to capture your eye image. So that was first explored in 1936. And then in 1960, the first breakthrough on acoustic speech models was explored. And in 1960, also the automated face recognition system was also explored, but I will take it up in the next slide or in more detail. But in 1960, the both speech and face become automation. And 1963, the complete automation of fingerprint was achieved. And again in 1963, we see that the automation of signature, especially for the recognition, is also achieved. So this is like both online as well as the offline signature was started to explode during 1965. In 1974, the first commercial system on hand geometry biometrics. So hand geometry biometrics is basically you put your whole hand and then you try to measure your width of the fingers, length of the fingers, and something like that. So it is mainly looking at the geometry of the hand. So this system was first deployed commercially in 1974. And in 1994, again, the first IAFIS, that is Automatic Finger Identification System from in the US was organized a competition on the fingerprint recognition. And then in 2003, the AFIS in Europe was introduced. So similar to the US system, so Europe is also hosting an automated fingerprint identification system. So they have a large database of immigrants, they have a large database of criminals, and they want to do the fingerprint recognition with that. So that is called AFIS. So that was introduced in Europe in 2003. So then in 2005, so e-passports was introduced. So idea of the e-passport is like, for example, if we take our Indian passport, so we just have our face image in our passport. So our face image is not digitally stored in any electronic chip. But if you go towards European passport or other countries' passport like US, there is an electronic chip associated with your passport. The main advantage of this electronic chip is we can store our identifier into it. For example, we can store our fingerprint, which is quite standard from 2005 in Europe, also in US, but the face is not yet been stored, but it is going to come in future very shortly. So we can store our biometrics there. So when you go to the border crossing or when you go to the other applications where you need to show your identification in terms of passport, then it is not essential that they use the face on your passport. They can directly read your fingerprint template from the card, and then they can take your live fingerprint from you, and they can do the comparison, and they can check directly whether it is you that is representing the passport. So that is what e-passport. So it is introduced in 2005. And then in 2013, the major breakthrough in fingerprint is on the smartphones. I think the early introduction was in 2008 or 2009 from some European company, but it did not go well with Motorola. So therefore, in 2013, I think Apple bring it to the market with iPhone 6 or iPhone 6s. So I think that become a major breakthrough, because bringing the fingerprint to the smartphone is quite challenging because of the computation problems and also because of the region that we can scan. So if you have experienced the iPhone with the fingerprint, you see that we have a small touch finger kind of thing it is also called as an home button. You see that the sensing is very small compared to the traditional fingerprint that you might have experienced when you give your data to other identification system. So when we try to scale the application, then the challenges are more because you cannot use the full scale fingerprint. You're using a patch, very small patch of the fingerprint. And obviously the minutia distribution is not very robust compared to that of the full scale fingerprint. So, but however, when you want to use the biometrics on the smartphone, it is mainly on 1:1, that is the verification system. So you already give your fingerprint with different space of your fingers. For example, like if you have some experience with iPhone, when you enroll yourself with the fingerprint, possibly you will be feeding your fingerprint by touching the touch finger sensor in different angles as well as different part of your finger. So in that way, you try to cover whole of your finger, and when you want to authenticate, then it can match it to the one of your enrolled fingerprint and make the decision. So that is where in 2013 the biometrics was rolled onto the consumer devices. As it rolled onto the consumer devices, the application of biometrics also exponentially increased. So because the smartphone has become a gate for several financial transactions, so today we can do all financial transactions on the smartphone, and the smartphone is based on the biometric. So biometric can be used as an identification to confirm all your financial transactions on the smartphone. Well, so with this brief history, so we can just take a small move to the face biometrics. So as we all know that any kind of biometrics need to be unique. So the face is one such biometric, which is quite unique. So it has become quite famous because it is highly convenient and it is a kind of acceptance for the data subjects. That means that so we can capture the face image with or without knowing to the data subjects. So that is the major advantage. So that's why the face recognition has been popped up to the surveillance scenarios. So the face image when compared to the fingerprint we need to have a dedicated device. You need to touch a device, and then due to the hygiene conditions like today with pandemic, it is almost like it is not a straightforward solution to touch these devices or have a contact with the devices when many people are using it for the same purpose, right? So by considering all these things, it is quite convenient for the users or the data subjects to use the face recognition system because it is mainly contactless. And from the surveillance perspective, it is also quite easy for the surveillance agencies to capture our image without giving any consent to us. So in case of any security threat or something like that, they can easily retrieve those images and do the analysis to recognize any culprit in that. So that is the major advantage why the face recognition has become so strong. So there is no dedicated capture device. High resolution cameras are available in the mass market today. So the minimum, because for example, if you take any kind of even the web camera, it is minimum of 5 megapixel or 2 megapixel. So which is quite big for doing the face recognition, because if you take the earlier face recognition system, people try to do it in terms of KB, size of KBs. But however, if you take the example of e-passport, again, we cannot store like 10 megapixel facial image on that because there is a lot of constraint on the storage of such a device. So, but however, the use of large high resolution cameras, especially in the surveillance scenarios, make the face recognition system more popular. And the more particularly, the visible spectral cameras are more purposeful sufficient. That means that so we don't need to have very complicated multispectral devices or the 3D sensing devices to achieve the face recognition. So it is still possible to use a acceptable size or acceptable, I will say like 1 megapixel or less than that, with a normal visible spectral camera can give you, with the today's technology, it can achieve an almost perfect face recognition system in very different conditions. If we go and see to the industry, they try to use a face image with a dimension of 24 x 24 or 32 x 32 to achieve a very good face recognition performance, especially in the visible spectrum. So these things make the face recognition system more famous today, And because of this, today the face recognition system is also rolled out to the customer devices like smartphone. Well, as a humans, how do we perceive and learn the face? There are several ways how we do it. So we try to see the person and try to learn how the person will look based on three important salient features: the shape, filter, also the wrinkles. So if you can see here, we try to analyze uh, whether the face is round, or what is the different types of shapes of the face, how is the chin is looking, what is the distance from nose to mouth, and these things are automatically recorded to us. And more particularly, we also look for shape of the lips. So this analysis of the human is also validated from fMRI image that can scan the activity of the brain when we are doing some activity. So what scientists have done is like they try to show different objects to the face, different objects to the human, and also the face to the human. Then they try to see how the simulation of brain was worked. They identify that there is a separate region in the brain that is particularly reserved to perform the face recognition. That means that there is a certain activation things happening in the brain that is reserved to recognize the face based on the shapes and the evolving structure of the face. But when we come to the machine, it is completely a different story, because it is going to be very challenging, because we need to teach the machine to understand how this face changes over the time, how this face changes over the different environmental conditions, also with the different lighting conditions, also with the different application scenarios. So there comes several challenges with the face recognition system. The first challenge is how we represent the face. That itself is a big challenge. So today we have a data-driven approaches like CNN. They learn themselves how to represent the face. That's a fantastic thing. But before that, it was truly a challenging thing to identify what type of features we are supposed to represent the face. And especially the generalization of the face samples. So generalization means that, like, for example, if you enroll an infant of newborn baby, like 1 or 2 days, can you identify an infant after 10 years or 20 years? This is called a generalization of face samples. I think with today's technology we are not able to do that, but maybe in the future we can achieve that. So that means that a lot of variation. That means the aging and the pose we try to interact with the face recognition system matters, and sometimes the makeup what we use. And if you have observed that, like if you have seen some kind of cricket matches or something, there you can see that the fans come up with makeup in the face with a different kind of kind of patterns on the face. So those kind of things will completely kill the face recognition system. So under those conditions, we are still facing a lot of challenges in achieving a reliable performance for the face recognition system. So the possible solution what machine can take is the visual pattern recognition problem, basically. So before deep learning, it was a visual pattern recognition problem. Since deep learning, it has become an applied machine learning problem. So more particularly, we look for in the pattern recognition problem, we try to see what are the different unique patterns that we can identify for a person, and we try to quantify those patterns in terms of a global feature or in terms of a local features. So in terms of in the global feature, the famous thing what people have tried to use is the texture-based features. So now it comes to the local-based features. So we try to use what are the key descriptors of the face. For example, the width of the eye, nose, the positions of the nose to the nose to the mouth, also the position of nose to the eye, position of nose to the ears, and so on and so forth. And then they try to recognize the human. Well, now we go in little bit detail and understand what makes the face recognition system fail due to some challenges. The first challenge, as I already mentioned, is the pose and the expression. So you can see that the person can appear in front of the camera with different poses if it is in completely uncontrolled scenario. For example, in the surveillance scenario, we cannot ask the subject to look only to the cameras. If it is completely uncontrolled scenarios, the subject will be of different poses. And depending upon the scenario what we are capturing, the illumination is also a challenging thing. So with respect to when we have a lot of illumination on the face, obviously we lose the information on the face image. So what is very important to understand with the biometrics is entirely depend on the characteristics. So since we're talking on the face here, so if we can find a face in the given image which can represent a characteristics, then it is a straightforward task for recognizing a subject. But if we are getting a noise together with the face, for example, having a lot of illumination, this will automatically change the distribution of the pixels. It automatically masks the uniqueness present in the face. So these things will introduce a lot of challenge. For example, the shading of the light here. So for example, you can see the left side of your image is almost not visible here. So these things will result in the loss of information. So when there is a loss of information, so almost all the techniques for the face recognition systems will fail. And also the other kind of problem is the expression, or use of different kind of expression. And of course there exist several ways how you can even trick your face recognition system. You can conceal yourself by doing this kind of special expression to the face recognition system. And also you can have an occlusion. And when we try to process the face in terms of in the photo, so for example, you have like a cartoon image, or you have like a very low quality face recognition, low quality face image. So the quality of the biometric characteristic is very important to achieve the good recognition accuracy. But the quality is not assured with respect to the different applications. So if you say I am going to do a constrained face recognition system, then we can expect a decent quality of the biometrics. But if you say I would like to do a face recognition system in completely unconstrained scenario, for example, in video surveillance, in day and night scenarios, at face recognition at a distance, face recognition in a wild, then it is going to become a very complex scenario. And the other kind of challenges what we face other than this is the resolution of the image. So when we want to do a face recognition at a distance, obviously your face will be in like 2 x 2 pixel, or it may be in like 5 x 5 pixels. So whole face will become a tiny face. So then comes a very big challenge, because most of the work in the super resolution thing, even with the deep learning, is basically on downsampling the high resolution images and then upsample to achieve the same resolution. But there are very few works that really address the comparison from low resolution images to the high resolution image. So that means that you will be given a real low resolution image, and without any prior knowledge on the image, we need to go to the high resolution image and do the recognition. So that is still an open problem, and it is a very challenging problem one need to address. And other very challenging problem is the twins. So the fingerprint is well unique for all the 10 fingers, even to the twins. Iris recognition system, wonderfully uniqueness. We don't have any issue with twins. It is unique for 2 eyes and between the siblings, between the twins and everything. But when it comes to the face, it is not the case. So when we have a twins, it is going to fail. So there are several studies that has been done on the face twin recognition, but still the recognition accuracy cannot be achieved. That is quite indicatable, because you have 2 face images that look similar to each. So obviously there is no unique characteristics that we can quantify. So this is also another open challenge that we need to face in the face recognition system. And other kind of sub-challenges that we face with our everyday lifestyle. For example, the image what you see here is the drug abuse image. So for example, if a person enrolled with a face recognition system will start abusing the drugs, then after 5 to 10 years, he will get a very different face. For example, in the left, it is before the drug abuse, and after the drug abuse, you see that the face characteristics was completely changed. So we have done some work on improving the accuracy for the drug abuse people, but it is a really challenging problem because of the small sample size and the variations that we have noticed after the drug abuse is very huge. So there are a lot of patterns on the face. that appears after the prolonged use of the drugs. So in addition to this, there are also other kind of problem. For example, the transgender face recognition. So that is also a quite interesting problem. Not much has been done there also. So for example, like I born as a male, I would like to change my sex to female. Then obviously your biological characteristics, including the face, will change. So your face will turn into a different gender. So that means that you're enrolling a male and you're trying to recognize a female. So that is also a quite challenging problem. So these things, when all these things come together into your database, then your face recognition system that we want to design must address all these challenges. Well, other kind of the attack is, for example, is on the disguise. So we try to make up with a lot of beards and all. Then obviously that may also mask some of our unique characteristics, and we can conceal ourselves. And the new kind of challenge that appeared is the presentation attack. That means that if you are a user of face recognition system, I will try to take your face image in some sense without knowing to you, or if I am your friend, I can go to your Facebook and I can download your face. Once I get your face image, I can print it, or I can put it on any of the electronic displays like iPad or the phone, and then I can present it to the face recognition system. And the face recognition system, which does not differentiate the live presentation or the artifact presentation, it does not care. So it simply takes the face image, and you are already enrolled in the image, so it will try to do the verification and it will say that you are verified. So this is a challenge what we are trying to address in the today's talk. So when we say what is the biometric system, so this is the standard block diagram that we have proposed in ISO ECSE 37. So basically it is having 4 functional units. The first is the data capture unit, and then we call the second unit as the data storage, and we have a matching unit, and then we have a decision unit. So the data capture unit is where your camera is placed. If you're doing a facial recognition, or if you're doing a signature, online signature, then the pen will be placed. And depending on the type of the biometrics what we are using, the data capture device will be depending on that. So if it is a voice, then it is a microphone. If it is a face, then it is a camera. If it is a fingerprint, then it is a fingerprint sensing. So the subject will present here is biometric characteristics. It will be sensed in the sensor, and once it is sensed in the sensor, then we do a lot of pre-processing. So we also call them as in features. The first pre-processing is the segmentation. That means that you capture my image and you're interested only in my image. So you take out all the background other than my face image. So we call that as the segmentation, or more particularly with face recognition, we call it as face detection. So once you do the face detection, we try to do some feature extraction. So this feature extraction is not essentially to be texture features or something. It can be anything. So you can decide what you want to do there. So once you have your face image, you extract and represent that face image in a very compact and discriminative way. So once you have this representation, you try to do the quality control. That means that the features what you have must be capable of captured all the characteristics useful for the recognition. So for example, if I go to my face recognition system, I cover my face myself, I will cover half of my face and I give my image. Then your face recognition system, what you have designed, must be capable of identifying that, okay, the face is a partial face, what you have got. So that means that you need to do a kind of quality control. So there are several ways how people do the quality controls, and today with deep learning, they are also evolved much in doing a very automated and robust quality control. So for example, you go to the face recognition in the dark and you want to do yourself, obviously in the dark, we cannot get anything unless you have an infrared camera. So if it is a visible camera, obviously you don't get anything. So in such a case, your system must automatically control the quality of the biometric characteristics captured by it. It should make sure that we have enough characteristics that can be used for the verification. So once you do the quality control and confirm that, okay, I captured a nice image, it is of all the qualities I can use for the recognition, for the deployed purpose. So then you create a template. So template creation again has a various aspects. So depending upon your use, you try to have a compact representation of the features, or you can use some privacy preserving techniques. There are several privacy preserving techniques today. So probably you can use several privacy preserving techniques, and you can have a nice template. So this template is nothing but a real number, so it may be in binary numbers. So basically it's a system property. So you can decide like what type of numbers you want to have it inside your face recognition system or the biometric system, and you can just place it in your data storage. So data storage will have a template. So once we have a template, so it needs to be very careful here, because the data storage is a kind of database. So there are several ways it can be hacked. You need to make sure that even the data is hacked, it is quite challenging to reconstruct your biometric original biometric sample, because then the attack will become very easy, right? So there are several ways how we can secure the template. There are several existing techniques to that. So we can use one of them and we can place the data storage in. So then in the second stage, when we do the identity, the same subject will come. We give the data, we follow the same chain here, we extract the filter, we extract the features. At the same time, we compute the template and we extract the template from the data storage what we have, and then we do the matching. So once we do the matching, it may be like a simple distance measure or the similarity measure, whatsoever, a complex classifier or deep learning thing, it can be anything. And then we get a score, and for that score, we see with respect to the threshold whether it is verified or not verified. So since the biometric system can operate in two operation mode, the first one is the verification. The verification is always one-to-one, and it is also called as two-factor authentication in some sense. That means that your biometric system already knows who you are. That means that you are already enrolled to the biometric system. It is same as like using a biometrics on the smartphone, right? Before you want to use a biometrics on the smartphone, you make sure that you have all your fingerprints or your face is recorded with different ways or in the different challenging things. So the system already knows that, okay, here he is coming, so in some time. So once the system knows who you are, then you come again and you present, okay, it is me. So then the system will automatically detect, okay, it is you who is already enrolled to the system. That kind of operation is referred to as verification. In case of identification, it is not known essentially. So probably the best example is the watch list. So imagine that you're going to attend a nice IPL match or something like that, and they have a kind of security system. They want to avoid some unknown people, or they want to avoid some kind of criminal people entering into the stadium. Then probably they have a nice watch list. So the watch list is having certain set of data subjects which we are interested in. In such a case, when everyone is passing through the system, they try to compare whether the captured image belongs to any one of them. So they do that they do that thing. So then we call it as 1:n. That means that we are comparing one with all and make sure that he is not one among them. If he is one among them, then the system will alarm and it will say that, okay, he is the one who is related to this. So we call that as an identification. So the system can operate in two things. So verification and identification, depending upon the application, so we can choose. Now if we translate this basic biometric block diagram towards the face recognition system, it appears like this. So we have an image or in a video. So with today's technology, I think it is always good to use video because we get more frames rather than having a single image. So then we do the face detection. This is nothing but a segmentation, what we seen in the earlier block. And in some applications, you may need to do the tracking. So if you want to see that some expressions, or if you want to see the liveness of the face, or if you want to do the other complementary things other than the recognition, it is always good to do the tracking. Once you do the face detection, you try to do the face alignment. So this is very important with any of the face recognition system, but with the new evolving of a deep learning system has shown that we can do the face recognition system without alignment. But before that, it is very much important we do the alignment. That means that we localize the eye region and we try to normalize the distance between the eye to have like 70 pixels or 120 pixels or something like that. And then we correct the rotation, and we correct, if possible, we correct the translation, and we register that image. So basically it is called face alignment. Once you do the face alignment, so we then do the feature extraction. So here we can use handcrafted features, we can use deep features or whatsoever. We can design our own features, so we can have multiple stack of features or whatsoever. So once we do the feature extraction, then do the template and then put it to the to your data store. So that is your feature that is your data storage. Once the probe data will come, then you match it with the matcher, and then you say, okay, this is the subject ID of this subject. So this is how the face recognition system is defined. So when we do the first step in the face recognition system, there exist several challenges. The face detection is not always robust. So it depends on type of the applications we are using. As I already mentioned, if you're doing everything in the very constant conditions, today the face recognition system is a kind of solved problem. But if you try to push the face recognition system towards the challenges that I already described, then obviously we have a lot of challenges come. So here is the one example of deep learning based face recognition system. So if you have a face images at different scales, so for example, the first subject appears with very large face, where the last subject appears with very small scale, still we have a system that can identify, that can automatically detect the face region. Even though it is a background image, we have some kind of shadows on the face and so on and so forth. But when you have a very much variations of the scales in the image, for example, in this image, we have a too big image in the front and too small image in the back, then obviously the false detection rate increases. So we can see that there are several false detections that has been happened. So these are the kind of challenges we need to deal when we try to do the face detection. And with the today's challenges, so we have most of them, because we try to do all this face recognition system on the social images, right? So it is always of low quality, with the varying pose, with a lot of expressions, with a lot of occlusions. Obviously, the challenge is exponential. So this is the open problem, and still several work that has been proposed based on deep learning and so on and so forth. But still, it is still a very open problem. Well, if we take some of the milestones from the face detection, so the first notable work is in 1989. So if you see the bottom line here, so these are all kind of rule-based methods and those kind of things. In the upper, it is mainly on the statistical things. So in 1989, the first work is on the rule-based method. So in case of the rule-based method, so basically we try to say that the face must be like this or like that. It should have a nose below the eyes and mouth below the nose and something like that, and then they try to detect. And in 1994, the neural network was passed, but however, it was not that robust because of the computation capability and also the lack of large-scale databases. So the neural network in 1994 did not get that much of success. Then in 1998, the skin models came into existence. So this is the example what I'm showing here is on the skin models. So skin models become quite prominent. So they use different color channels where they can filter out different color components and identify the skin region associated with the color. So, but however, it is well noted that when you have a lot of variations in the illumination, obviously the skin color models will fail. So then in 2000, it is mainly on the statistical models. So basically the statistical models try to have a preview like how your face should look. Then it try to have an inference on the given image that, okay, this region belongs to the face. So then in 2001, this is a major breakthrough in the face detection, which is the art cascade or the Wheeler-Jones method, which is famously called. So what this Wheeler-Jones method will do, it is as illustrated in the video here. It is having a set of features. So we call that as an all wavelets. So these features are slided over the whole image, and And we have a group of weakly classifiers. We call that as adaptive boosting technology. So we have set of weakly supervised or weakly set of classifiers, and each of these classifiers are already trained on the specific features associated with the face. So once you slide the windows with these features, and these features are divided whether it belongs to the face or it belongs to the non-face region. So then you slide your window towards one region where you get more response for the face. So this is the well-known or kind of a major breakthrough in the face detection technology. So then comes the deformable models. So deformable models will take one step inside because they try to see different aspects of the face with respect to the pose and also with respect to the variation in the illumination by using the gradients of the image. So they use HOG, histogram of gradients more particularly, and then they try to learn a model, so which can be used here to identify the face in more robust nature. So then in 2015, the deep learning was evolved, and MTCNN is one of the quite famously used face detection tool. As you can see here is even with the occlusion of the face, you can detect the face region. With the pose, you can still detect it. With the expressions, you can detect it. Even with respect to the variation in the ethnicity, we can still achieve the reliable face detection. Well, now coming to the face recognition, as I already mentioned, in 1960 is the first time where they tried to do the automatic face recognition system. But since 1991, the face recognition system was not in that much of mainstream. Only the fingerprint recognition was widely used. And in 1991, it has become quite famous by the introduction of PCA, the principal component analysis, where given the data, we try to analyze the variance. With respect to the variance, we try to see how the given test image will be represented in the subspace. So the PCA has emerged as one of the breakthrough in the face recognition system in 1991. Since PCA in 1998, we have landmarks. So these are some very important breakthrough because most of the technology today is based on the facial landmarks. So that means that we try to see the shape of the face and also the noses and the eyes and your eyebrows and structure of the mouth. It is more towards the shape of your facial image. So the landmarks has emerged as one of the major breakthrough in 1996. Again, PCA has been improved towards facial linear discriminant, where you try to optimize intra versus interclass scattering things. So again, you will learn a new kind of the subspace with maximizing the Fisher discriminant analysis. Well, again, after FLD, then we are having graph. So this is called as so when we already have 1995 the landmarks method, then they try to see like can we connect these landmarks and have an elastic graph of the face. So elastic graph of the face is very good very good breakthrough in the face recognition system because it can give a kind of nice shape representation of the face, but still when we have a major expression on the face, this kind of techniques will fail. Then in 2000, there is a breakthrough with the kernel methods because we started to get more and more data. So it has become more challenging to use the high dimensional data. So it is always easy for us to project the high dimensional data to the lower dimension. So when we want to do that, there are the techniques called as kernel techniques. So you try to use the kernels, put the data in the lower dimensional, and then you do this PCA and FLD, and you can achieve a much better performance and robustness to the various kind of noises. Then in 2004 comes the local binary patterns. So local binary patterns are basically a texture feature recognitions. So before local binary patterns, the people have used the Gabor filters. But since 2004, the local binary pattern has become a kind of state-of-the-art in face recognition system. So since 2008, there is another breakthrough that is a sparse representation. So until the introduction of sparse representation, most of these face recognition systems keep working in L2 space. Now they're slowly moving towards L1 space. So where they try to represent each subject as in sparsely represented towards all other subjects. So this is called in sparse representation. So once they have a sparse representation, they achieved a very good performance, but the competition is very high. But in 2013, we have a deep learning. So with the deep learning, I think like with today, we have several networks available for the face recognition, but I would like to bring to your notice two important face recognition network. The first one is the FaceNet. The FaceNet is a very nice architecture which is inspired from the ResNet kind of thing. So there they try to use like 225 cross 225 face image to train the face recognition system, and it is one of the outperforming face recognition system in many of the computations, many of the public computations. And another advancement in the face recognition is with respect to the arc face. So that is also very interesting because they try to learn like how this gradient change when they try to optimize the face recognition system. But there they reduce the input image size to 112 cross 112. So which is quite a good improvement, because when we think of this deep learning system, we need to have million of images and you need to have a good computation if you want to build from scratch a nice deep learning CNN. So this is a very challenging thing. So with introduction of deep learning, so I think the face recognition system has elevated almost to the realistic system that can address various kind of aspects. But even though it may not work well where we lack for the data. For example, like in case of transgender face recognition, we cannot achieve any more good results with deep learning because we don't have million subjects who have this million subject database who have this transgender transition. And also when it comes to the other kind of problem like makeups, other kind of problem like for example, like drug abuse. So we don't get data, right? So once you have a nice data with you and once you have a variations in the data represented, then it is always a good solution to use deep learning. Well, so once we have this face recognition system to be more accurate with respect to the time, obviously the consequences of that is the vulnerability of such a system towards the presentation attack or the spoofing attacks. So you have a nice, highly performing biometric system. That means that your biometric system is capable of recognizing you with different poses, with different variations in expression, with different variations in the lighting conditions, with different variations in the environmental condition. That means that the system is highly accurate. So once you present a system, the photo of your phone, then obviously it must get accepted, right? That should not happen. So then if the system will become more vulnerable. So then comes the presentation attack detection. That means that your system is good, doing wonderfully well, but it is more vulnerable for these kind of attacks. So when we look into the ISO IEC 30107 scope, so we have this presentation attack. So this is a general block diagram of the biometric system. So there are 9 ways how the biometric system can be intercepted. That means the 9 ways how we can attack a biometric system. So these 9 ways can be broadly classified into 2 types. The first thing is the direct attack, and the other thing is indirect attack. The direct attack means you're trying to attack a system at data capture unit. So this direct attack is also called as presentation attack. So this is one of the easiest attack one can perform on the biometric system, because attacker does not need to know how the biometric system is working. So you don't need anything. You need to get access to the system. You need to get access to the artifact of a person whom you want to attack. Only with the 2 things he can achieve. He can easily deceive and achieve what he intends to do with the biometric system. So then comes the indirect attack. So indirect attack is a kind of skillful attack. So you need to understand how biometric system work, what exactly you want to change, and in what time limit you want to change. So for example, in the 2 what you see here, we try to modify biometric sample. That means that The image which is captured by the biometric system from the camera. From the camera, there is a channel to the signal processing unit. There you can attack that channel, communication channel, and inject the video or the image that you want to play to the biometric system. For example, you want to attack my biometric system, but you don't have access at the data capture unit. So what you try to do is you try to hack a biometric system in which I am enrolled. Then you attack the data capture unit with your software. Then you inject the video of mine into that. So once you inject the video, then biometric system thinks that, okay, this is the video I am getting, so I will do the process and give a decision on that. So this is called as an injection attack in general sense. And we can also attack the signal processing unit. So if you see that, okay, the communication channel is highly secured, then can I attack the signal processing channel? So this is also you can do. The signal processing channel includes the feature extraction, quality assessment, several things come into picture until you get your template, right? So from the image to template, there are several things you can do there. So you can go and say, okay, this is the final template. This is my template. You inject that template there to the signal processing. Then again, you can deceive it. Then there is a channel between signal processing to comparison. There also you can change what you want to do. Again, you can change the comparator itself. So if the comparator is saying, I am accepting you, you can go and hack the comparator and say, okay, don't accept anyone. Make it still. So it is possible. So you can go and attack the comparison system. Along the same line, you can go and attack the data storage of the biometric system. So all these things requires from the 2 till 9 requires a lot of skills. So it requires the knowledge of biometric system. You need to know how to hack a system. You need to know where to hack a system. And all these biometric systems will operate with the time scale. So for example, in the presentation attack, in the very one, so you'll be given 1 or 2 attacks, right? So when you want to present yourself to the biometric system, there will be a limit on number of attempts that you can use. So for example, you go and say like, I will present myself to the biometric system. It will say, okay, first time you did not recognize, okay, second time you did not recognize, third time you did not recognize, then you are timed out. It is same as like entering the password to your system, right? If you enter 3 times wrong, then you may not enter it again for like 20 minutes or 30 minutes, or you might be permanently suspended. So biometric system also works in the same principle. So there is a timeline for everything to be done here. So you need to be very clever and make sure that you need to do these kind of attacks, especially with the indirect attack. So there are several ways available in the literature way to do the indirect attacks. The ill claiming attack is one of the prominently explored field in the indirect attacks. But in this talk, I'm mainly concentrating on the presentation attack, as it is quite easy, and today's face recognition system, so I'll leave on now. Well, to make the problem less complicated, you can just see in this video what is this presentation attack. So if we have a subject who is walking into a door, here we have a camera, for example, so which is doing a kind of face recognition system. If there exists nothing, then obviously the person will go and he will give his face image to the camera. It is recorded. If he is same guy, and he will be given the access. But while he is doing the access, we can see an imposter here who is carefully capturing his biometric characteristics. So he captured his biometric characteristics, then he got the image, he go inside and he start generating the artifacts. Once we think of the artifacts, so there are several ways how you can reconstruct the captured biometric samples. So you can, for example, in the face, the very famous way is to like simply print the image, or you put the image in the display, or you go and generate a nice silicon mask, or it depends on the application what you want to do. So there are several ways how we can generate the artifacts. Once you generate these artifacts, you simply take them and present it to the system and you get inside. So this is how the presentation attack will work. So what I want to stress here is the biometric system what we are using here must be secured to automatically identify these kind of attacks. So there are several real life examples. This is not a fantasy story because, for example, we might have seen many Hollywood movies, even in many Kannada Upendra movies. So it is very common that people come with a mask, right? So they come with a mask and they try to cheat people, they try to do other things and so on and so forth. There are several real cases that have been reported in media. The one such real case happened in June 2012 in London. The person here, so he tried to wear the mask, which is shown in the left of your figure here. So this is a complete head mask. So this is basically on the silicone, and it costs a lot of money. But he tried to have this mask, and this is how he will look when he wears this mask. With this mask, he tried to rob several stores, and he did that for several years. And it took some time for police to identify this person. And then another real story is in January 2011. Person in the left is a Korean. So he tried to have a mask of the old person who look in the right of the image here. So he used this mask. He has a passport with this masked image, and he already deceived the immigrant agents in the Hong Kong airport. So he went with this head mask, with this structure, what you can see in the right hand of my right figure, and he deceived the immigration process. He boarded a flight to the Vancouver. So then in the flight, he felt very hard to wear this mask. So because when you have this silicone mask, obviously, like now with pandemic, we have all experience how difficult to wear a mask. So obviously it is the same. So it is difficult to breathe. And also if you have a silicone mask, so then it will absorb a lot of heat from you and it will become too much of warm. So we cannot hold it for a long time. So because the flight from Hong Kong to Vancouver is quite long, so obviously he went to the toilet and he changed his mask. So he took off the mask and he come back and sit in the flight. Then the person sitting next to him informed to the air hostess about this, and then he caught in the Vancouver. So this is also a real case. There are several examples. Most recently in Brazil in 2019, last year. So basically, he's a person who has been prisoned for the drug peddling or something like that. So he tried to prepare a mask of his own daughter. So he wear that mask and he tried to escape from the prison, but he was caught in the very last minute. But he was successful in deceiving many officers while he was escaping from the prison. So there are several cases. So the most recent case happened last year in Delhi airport. So if you have read through the media, so you can see that like the person in the right here, so that this guy used to disguise himself as another person. So he has a fake passport with another person with a disguised photo. So then he went to them and he completely deceived immigration persons, and he already boarded a flight, and inside the flight he has some kind of behaviors because of which he has been arrested, and then they identify that okay, he is doing a disguised attack on this. So all these presentation attacks, either in terms of presenting an artifact, or either in terms of putting up a 3D mask, or either in terms of putting up a disguise, is a real thing. So it is happening all over the world, and it is increasing to happen in many applications. So when we come to the smartphone, it is more complicated. So whenever the Apple releases its new iPhone, except for iPhone 12, all the iPhones has been packed within 2 weeks or a month of its release. So there are several videos available in the YouTube. You can see that how they use different kind of artifacts to spoof fingerprint, to spoof face, to spoof even iris recognition. So for example, if you see the glass here in the bottom of the slide, so this is a special type of glass they prepared, and they try to override the Samsung iris recognition in the Samsung S20 or S10, I believe. So almost all the biometrics that has been introduced, especially in the consumer device, can be hacked today. So it is very much essential that we need to devise a technique that can automatically detect these kind of attacks. So there are certain things that are well defined in terms of in the vocabulary in ISO IEC. So these documents you can find yourself, because it is very important for you to understand like what the word means. The vocabulary is very important for you to understand if you are interested to work in the field. So there are several things they define. What is presentation attack? So presentation attack is defined as like a presentation to the biometric capture system with the goal of interfering with operation of the biometric system. So this is called presentation attack. So how we can attack the system? We can generate an artifact. So we can generate different types of artifacts, and we go to the biometric system and we try to interfere it. And what is presentation attack detection? So the presentation attack detection is an automatic determination of presentation attack. So we need to automatically say once we capture the image whether it is a real image or it is an artifact image. And we also have other kind of vocabulary. For example, we use imposter. So if you say what is imposter, so this is what the definition we use. Similarly, we have an identity concealer. So for the identity concealer also, it is given it is given a well-defined definition. So concealer means you are trying to conceal yourself by getting verified in the biometric system. So for example, if you're crossing a border and automatic border gates, you want to say that, okay, I am in the blacklist, I don't want to get verified automatically. So then you try to disguise yourself, you create a new kind of expression on the face, otherwise you will put up a nice makeup on your face and so on and so forth. This is how you conceal it. Well, there are also other definitions like presentation attack instrument. So attack instrument is nothing but an object. So for example, if you use a print attack, then presentation attack instrument will be in print. If you use a display attack, then presentation attack instrument will be an electronic display, what you use. And similarly, the artifact. Artifact is the object that we try to use. So it is nothing but a copy of a biometric characteristics we try to present to the biometric system. So what are the different types of presentation attacks we have today? So there are several ways how we can devise a presentation attack instrument. So mainly it is of three types: artificial, human, and other natural. So other natural never exists, but it is kept open if something exists in the future. So mainly we have like artificial. So it may be a complete or it may be a partial attack. So for example, like you take a complete photo of mine and try to deceive my biometric system, or you just take, okay, I will take only the eye part, or I will take the mouth part, I will take the nose part, and you will use a partial attack on the system. And when it comes to the human, attack instrument may be an lifeless, like your print attack or display attack. It may be an altered attack. So for example, if you're using the fingerprint attack and assume that you have been kept in the for example, like you will be in one country and country will restrict your entry again based on the fingerprint, then what you do is like you try to scratch your fingerprint. So there are several real cases happened in US and also in the Europe where they try to alter their fingerprint. There are several ways to do it. You can simply scratch your fingerprint, or you can go to the nice surgeon who can alter and give you the complete new fingerprint. So this is also there. So there are several cases that has been investigated. I think Professor Jain has written a nice paper on this. Probably you can Google and you can see that the altered fingerprint attacks are quite prominent in real life. So there are other kind of attacks, non-conformant and then conformant attack, resist attacks, and so on and so forth. Well, so when we talk about the attacks, we talk about the first important thing is the imposter. So imposter means I am the one who is trying to represent as someone else. So this is called as an impersonation attack. So depending upon how we are using the system, it may be an verification 1:1, or it may be an positive access like 1:n. It's an identification system. The best example for the imposter attack is the look-alike. You can see my cursor there. So these two persons are look-alike. And the other kind of attack is the makeup attack. So you try to make up like me. So there are several modern makeup technologies. You can just Google Angelina Jolie makeup. You will find a lot of images where the people try to make up themselves to look like Angelina Jolie. So there are several analyses in the real-time analysis that has been done, and we are also doing several work on that. And we are very much convinced that the commercial face recognition system, what we use today, is completely vulnerable for these kind of attacks. And especially when we deal with the face recognition system, the look-alike and the doppelgangers are very common in the face recognition system. So one of the analyses was also mentioned that for one person, there are 47 look-alikes or 47 doppelgangers. So then imagine the stress on the face recognition system in providing a highly robust verification performance. So the second type of attack is the concealing attack, right? So what we do with concealing attack is we try to avoid ourselves being verified by the biometric system. How do we do it? So there are several ways how one can do this. So for example, if you're in a surveillance scenario here in the bottom figure, so you can see that the person is wearing a bright flash. So when you have a flash, all your surveillance cameras, especially that works in near infrared scenario, will get into the saturation. So they cannot see what is your face because the light is very bright and it will become saturated. The pixels will become saturated. So we can use this special kind of light, or even a simple battery available in the stores can also be used. You just plug it in front of your face and mask the camera. So if you have noticed in the media, so especially in the last year, there were several protests happened in the Hong Kong, and they try to deceive these surveillance systems. So they try to show something constantly for the surveillance system. They put some kind of posters to the surveillance system so that it don't record the demonstrators. And they also use special kind of mask and special kind of lights, especially on those eyeglasses, so that it becomes challenging for the face recognition systems. So these are the real life challenges. These are all happened in everyday life. These are all covered in the media. So it's not something speculation. So these are the real challenges one we need to address with face recognition system to make it more robust. So the topology of attack types, there are several ways how we can attack, how we can generate the presentation attacks, especially the impersonation attack. The first thing is the photo attack. So as I already mentioned, so you capture the photo and you use different kind of printers. It may be high quality printers, or it may be a photo studio printers, and so on and so forth. So once you generate these print attacks, so it is quite interesting to note that when printer prints something on the paper, the ink will spread. So since the ink will spread with these kind of printers, so it has a different kind of texture pattern compared to the real face. So most of these presentation attack techniques will try to encache those kind of characteristics to identify this. So when we generate this kind of the print attack, we need to be careful that these attacks are high quality enough to be deceived by the face recognition system. Because remember that all the face recognition system, all the commercially deployed face recognition system runs with a quality control. If the quality is less, it won't accept your face image. So it is very important that high quality face image is generated and it is presented to the system. So other kind of attack is the video attack. You simply record a video and then you present it to the system. So since it is a video, the system will come and simply capture this image, and if there is no presentation attack detection scheme inside the system, then obviously it will be verified. And the other kind of attack, which is quite prominent and which is more practical in many applications, is the 3D mask attack. So if you have your 3D face, so I can generate a silicon mask. Of course, there are several ways how we can generate a mask. We can have cost-effective $5 mask. There is a website called that'smyface.com. So you just upload your 4 images and pay like $5 or $10. You will get a mask in 1 week or 2 weeks time. But however, those kind of masks are easy to detect because the quality of the material that we use to generate the mask is easy to be recognized with simple texture detection schemes. But however, with the silicon mask like this, so it is very expensive, very fast, and they use a 3D. And they use a 3D technology to develop these masks. Therefore, they are quite accurate in terms of the geometry, because it is based on the 3D sensing, and also the quality of the silicon is similar to the quality of the skin, and also it absorbs the heat. So that makes the presentation attack detection schemes more challenging. And of course, you can use the partial masks, like you don't have to generate a full mask. For instance, if it is a completely uncontrolled system, you can just have a partial mask and try to deceive, try to attack the face recognition system. And when it comes to the concealing attack, so the extreme makeup, so there are several ways how you can make up yourself. So it is very cost effective, and if you have some skills, you can make it to look more natural. And obviously, these kind of makeup attacks are very well used in several real life scenarios to deceive the face recognition system. And there is a partial occlusion, as I already mentioned, that we can have a special kind of textures on the face. If you have this kind of textures, for example, in the figure where I am cursor is placing here, so these kind of filters will not only deceive the face recognition, it will deceive the face detection, because the pattern what they have used is similar to the are features which are used in Euler-Jones method. So for example, if you are running a Euler-Jones method, then even the face detection is almost impossible. So this kind of additional patterns present on the face will bring the face recognition system to the another level. So therefore we need to be careful when we have these concealing attacks like this. The face recognition system normally fails. And obviously you can have a nice glass with a simple LED light blinking on that. And this is what I shown with the Hong Kong protest. So basically these kind of things what people will use to deceive themselves. And other kind of natural problem that we experience due to the greater change in the technology and also the societal aspects is the plastic surgery. So every time people try to go and get surgery to look themselves more beautiful or look themselves in a more different way, and so on and so forth. So these are all the ways how the face recognition systems can be conceived. So if the person is plastic surgeon, then it is very difficult for the face recognition system to be used to recognize the same person. Well, now coming to the presentation attack types. So the presentation attack detection was quite active from 2010 or 2012 it started. So before that, there were several techniques, but it was sparsely addressed in the community. But since 2008 or 2010, it started in the mainstream. So it emerged as one of the subtopics in all major conferences of the biometrics, and a lot of people started working on it because the availability of the consumer biometrics on the consumer device, and the availability of the various types of devices, and availability of face recognition system on even the cost effective manner has motivated these kind of things. So there are two types broadly we can say. So first thing is the hardware based. So when you design your face recognition system, you can also design a special kind of hardware that is focused only to detect the presentation attack. That's the one way. And the second way is you can have a single hardware that can be used for both face recognition as well as to perform the presentation attack detection. The one example, or there are several examples. So one such example is on the using a special type of camera called as planoptic camera or the light field camera, or we can also use the multispectral cameras, or we can also use a simple 3D sensing. We can say like, okay, I will go beyond the infrared range and see shortwave infrared sensing. So depending upon the quality of the artifacts, we can decide what type of sensing we need to identify and recognize the attacks. So when we say hardware attacks, it is a combination of one cameras with several cameras. So I'm just shown only the camera, but there are several ways. So you can measure the pulse with physical connection, you can measure the pulse in a different ways, and so on and so forth. So whenever we use additional hardware or the one hardware together for the face recognition system, then we call it as an hardware-based technique. So then is the second one is the software-based technique, which is quite challenging, and this is the way ahead for the presentation attack detection, because the software-based techniques are challenging to implement, but it is easy to deploy and easy to scale. So we don't need any special hardware for the existing face recognition system. If you can develop a nice software-based techniques, so then we can use that as a software update to the existing system, right? So that is where the software-based techniques are quite popular in the literature, because it's also challenging, but it has several applications. So there are several ways how people will do. For example, in this video, you see that like there is a magnification of the video to identify whether it is a real face or a real eye or an artifact eye. For example, if you are presenting a print attack, obviously you don't see the small motions which has been magnified, right? So because the photo is constant, there will be no movement of the eyeballs, there will be no small movements of the eyelashes, and so on. But also with the software-based techniques, we can see the texture-based method is highly prominent in all kind of biometric modalities because uh, the majority of the literature what we have used, what you have seen in the presentation attack try to address either display attack or the print attack. Very few are considered a high-quality silicon mask attack, but majority of them are on the print and different types of prints, high-quality prints, and so on and so forth. And it is well noted that when you print a photo, obviously there is a scatter of the ink, and this characteristics can be well quantified using local binary patterns, so LBP. So LBP has been well proven in the field for past 8 to 10 years, and it has been used in several public computations, and they show that okay, so with LBP we can quantify the print attacks. But still, there is a lot of challenges ahead. But it is not like the problem is just solved by using an LBP, because LBP is also is also very much sensitive to the various kind of image variations. So then we have other kind of software based technique where we try to see the 3D structures.